A lot of the things that Tim was saying in his presentation really, really resonated with me. There's just the notion of creating more value than you're pulling in resonates so strongly with us because, first of all, everybody in the 3D printing community is learning from each other and helps each other along. And for us, especially knowing that we're able to kind of lead the way and provide a lot of that infrastructure, it means a lot also in terms of being able to look at what people are doing with the MakerBot and getting a sense of what might be coming. To tell you guys a couple of really good stories, my friend Gianpaolo is actually in the audience right there. Please stand up. Let's continue the theme, actually. He's working on a fantastic project right now that involves stringing up 25,000 LEDs on a bridge in San Francisco. So he did the prototype on the MakerBot, and then of course the next logical step would be, okay, so we go to mass manufacturing. But he's like, wait a second, hold on. Maybe we don't need to do that. So he started running the numbers, and he's been thinking about it. And it turns out it's quite feasible to not have to make that step. So that's really interesting, right? That's another story is that I had an ITP student from NYU with me at MakerBot for the past semester. And he started looking at introducing what he called the malleability of life to kids, right? Kind of introducing with this design concept that everything is changeable and that they don't have to be restricted to what's out there. So he took clay to them. He took real clay, and he said, why don't you go ahead and make the phone that you want to make? And they just kind of formed these crazy hamburger phones. And then he brought them back, and he scanned them with 123D Catch, and then he printed them on MakerBots and put walkie-talkies inside, brought them back to the school, and the kids' minds were blown. They just couldn't believe it. They couldn't believe that these things worked. One of the questions they said was, does this actually work? It's yeah, of course it works. And one of the things that made me so happy was that he was introducing this element of very early on in these kids' lives. These are third graders. He was basically telling them, you don't have to take anything for granted. It all works. You just have to deconstruct it and then make the thing that you want. So, and it was just awesome to see him go through the process of doing it with a MakerBot as well. Now, one of the other stories that I really love telling is the fact that when you work at MakerBot, you get to have a bot on your desk at any given moment. And it's not just the engineers, it's not just R&D, it's everybody. So there's HR bot, there's accounting bot, and everybody pretty much builds their own bots, which creates this really interesting effect of we're kind of living just a tad bit into the future. And you have very casual conversations to the effect of, hey, I'm going to a birthday party later, 9-year-old, you mind printing something up for me? Mine's busy right now. It's very casual. It's oh yeah, sure, no problem. So people will print stuff up, right? Usually it'll be stuff that's about this size. This is a hand. And the cool thing about this one is that this one was actually scanned from a real hand. So now when you start looking at the fleshed out ecosystem, one of the next awesome things that's going to come is obviously going to be 3D scanning. And it's already there. But it's so what happens when you can actually accomplish that too? And you start to see things like 123D Catch pop up. It's awesome. You start to see things like what people are doing with the Kinect. That's also great. Now, one of the things that I think about a lot is also fleshing out what people can actually do with the MakerBot that doesn't just consist of plastic objects, right? And I have one thing with me, which is the Botmobile, which is a nice, solid remote control car. Now, a lot of work went into designing this, but after the design was over, we uploaded the files to Thingiverse. And then people can just either buy a kit from us with all the non-printed parts or just follow the bill of materials and get things individually, print out the parts, and snap it all together. So it leads you to the next point, the next logical point, which is, so what happens if it breaks? I actually broke this on my way here today. So you break it, doesn't matter, just print it again. Or you're tired of this one, your kids are tired of this one. I think kids get tired of toys, I'm not sure, but if they do, it's awesome because you can download a newer version of the car and put that together. So that's one of the next steps. Yeah, these are, it really stuck with me what Tim was saying, this whole notion of creating more value. So what we're doing is really fleshing out that ecosystem.
Talk a little bit, so, and you were telling me previously as application development director, you're trying to figure out what people are going to do with 3D printers. I've always said the beauty of the maker market right now is people want MakerBots and 3D printers. They don't know what they're going to do with them, but they're just those kind of people. It's But sort of for this to really grow, you're going to need to really figure out some of those applications.
So one of the fabulous things about it is that we also run Thingiverse, and there's this like elaborate community of like motivated, fascinated makers who upload new things every day, right? It's like, it's over 15,000 things at this point. So part of it is just kind of like watching them and seeing what direction they take it in. So the first moment, like years ago at this point, somebody printed a part and then took an Arduino and put it together where we're like, oh, that's going to be interesting. And just like a lot of that has started happening. But beyond that, like a lot of it right now is focused on us and other people who are very skilled in 3D design, doing a lot of like grunt work and like doing a lot of the designs that then people print out. But then like the next interesting thing is going to be like the input part of the ecosystem of how do you make it easier for people to either not have to like learn 3D Studio Max or like being able to use like easier tools or even just use applications that create an interesting output.
Do you think there's going to be a design market around?
I think eventually, but so far the community has been very focused. It's a very just like free and open community of distributing STLs, which is the file that the MakerBot uses, and that'll come. But I think we're a lot earlier on in the process where we don't really have to think about that. What we should be all thinking about is just making sure that the paths of communication are completely open and accessible to everybody.
So one last thing. So from last year to this year, MakerBot has gone from being a kit to being now the replicator really is a finished item.
Yes, a lot of that comes from a sincere like listening to like who our customers were and who they are going to be, and understanding that people want to get to the point where they're printing a lot faster. So yes, a lot of it is like maturing and moving a little bit beyond like the hardcore maker community, which is like, you know, building kits, and moving more towards allowing people to make things with the MakerBot, which is the core of like what we want.
Okay, great. Well, you have the replicator out,
on
the showcase, and we'll see you all around there. People can ask questions and sort of look at it in more detail. Thank you, John.
Thanks.
Okay. Andrew, come on up. You're wired. Now, Andrew has some slides. Can you bring those up? So, Andrew, come on over here. You know, I've run into Andrew. Actually, is a true inventor. Has been at most maker fairs and with his son. And you've been involved with jetpacks and all kinds of, you know, wild things. But I just ran into you recently, and you were really excited about the things you were building with 3D printers. And I think a lot of us are sort of, we want to see beyond the, you know, tchotchke. We want to see functional things. We want to understand what you can do with a 3D printer. And I think you've been doing some experiments. And if you just maybe walk through what you're doing here a bit.
Sure. I look at a 3D printer like a regular printer. It's a tool that you have at your desk, and you just casually use it to bridge whatever gap you have in a design. And some of the things, and at the bottom here, and this is a little one that I adapted. This one has a Make logo on it, but if you look, there's this whole process where you have an idea. And the idea is to make this demo thing called a gizmo. And what the gizmo does is it's going to spin a logo around. It started by taking a 2D image, bringing it into a CAD program, a 3D design program, whatever flavor you like, and designing a mechanism. And this mechanism simply has a crank and some gears. And then making it printable. And that next step about making it printable is pretty critical, because you can embed these in support structure that you can never remove or becomes very costly. So there's a little bit of a learning curve there, but once you make it printable, you then print it. And the last part of it is, and the most important part, is you enjoy it. You use it and you enjoy it, because you really want to print things that you enjoy or other people are going to enjoy, and they have to be complete things. And these are the bridges from the Arduino and a lot of the circuitry things that are available. How do you encase those in something that's usable, a user interface, so to speak, that's a mechanical for everyone to have? The thing about making with a 3D printer too is you want to make things different. And again, you can come up and look at these later. There's an exploded view of this gear and this motor and this holder and all that, but the so what of that is that gear, that was 8 minutes and 8 cents to print. You know, if I had to order that gear from Grainger, it might have been like $4 and $7 shipping, and I'd get it 3 days later. I can print that, and if there's something wrong, I can reprint it in 8 minutes, and it costs me 8 cents again. So
what kind of printer are you? What were you printing it on?
In this particular one, it's the up printer, but I'm really agnostic about printers and software. I think they're all great, and they're all getting to a point where they're getting very, very usable. You know, the little pinion gear that's on the motor too, you know, that's 3 minutes and 3 cents. But that little orange piece at the bottom, the little self-locking shaft, I call that the priceless moment, because that thing, that's a split, has a little split bifurcated finger, and I can just, even on this one, I can just easily pull it out by hand. I can push it back in, and I can run this whole assembly at, you know, 500 RPM with no problem. So having that ability to make these things that are serviceable, that you don't necessarily need a screwdriver, it's just mind-blowing. In the past, I've done a lot of product development. To make that little shaft, I would have had to make an injection molded tool, and probably the first one wouldn't have worked. I can now just print it. That design actually took me like 15 minutes. I printed the first one. I saw, oh, there's a little mistake in it, modified it, printed it again, and ta-da, I had a part that, you know, would have taken me weeks or months to really suss out.
Great. So what's next here?
And then finally, you know, with a 3D printer, you can be prolific. I mean, you can try things that you wouldn't have dreamed of before. So really just boldly conceptualize, how do these things go together? Is it a friction fit? You know, does it have a special screw that you made, whatever? And you adapt, evolve, and reprint. So you print that individual part rather than print the whole assembly, and you say, is that a good part? And if not, you can just change it right on the fly. It's like when you run an Adobe program, you design something, and they're like, oh, it's the wrong color, or it's the wrong size. You throw that piece of paper away or recycle it, and then you print another one. Well, the same thing's here. And just some of the craziness is, oh, and then you compress the design development too, because you have those turns immediate. Some of the crazy things, there's an airsoft BB gun, and that was done as a design exercise, but it holds 2,300 rounds. It shoots 1,800 BBs a minute. And it all goes together with press fits. There's no screws, there's no glue, there's no tape. Models of, and this was before the Billionaires Boys Clubs announced going to asteroids, but you know, printing an asteroid, and the asteroid was on Thingiverse, it's Eros. But what was missing was the spaceship that went there, which is the Near Shoemaker. So we created the Near Shoemaker and made a display model out of that. And then finally over here, there's a thing called a CubeSat. And this particular CubeSat actually uses an Arduino as the brain to power it. But it's a small satellite, and even just the kits normally cost several $1,000s. Well, now you can design and print a kit for $20. So it's just amazing. And then some other things that are up here just quickly. This is a model for a functional turbine jet engine. So here, this is just the componentry, and it all disassembles, and you can come up and take a look at it, and it's all the bits and pieces, and this is the same thing, just printed in color so people could get around the fact that it wasn't. Here is also a iPad stand, and we needed a special iPad stand. We couldn't find one, so we printed one. The design took about 2 hours, and then to print it actually took about 2 hours. And this is all put together with dovetails, so no screws, no tapes, no nothing. And then finally, just on a special project is, this is an astronaut with a little jetpack on it. And as Dale mentioned, I'm into jetpacks. So the file, though, it's a contiguous file, so it goes to the model, and this is actually the controller. It's a digital fly-by-wire system, but it's actually all modeled and printed in 3D, and it's actually functional enough to use for some of our testing.
That's great. Thank you, Andrew.
Thank you.
And you'll be out there.
Yes.
Greg? So Andrew is well worth talking to if you're interested. This is Greg Bornstein, who's author of a new O'Reilly book, Making Things See. You've been exploring the Connect platform and a lot of things, and just want to you're going to tell us a little bit about what some of the applications you're seeing.
Yeah, I've got a couple slides up. I'm going to tell you about one specific application, actually, that I began and a student of mine has now taken further. So if we can bring up my slides here real quick. So a little more than a year ago, I was at Health 2.0 Hack Day in Boston, talking a little bit about the Kinect, and I met a psychiatrist named Dan Carlin, and he told me about a set of involuntary motion disorders called tardive dyskinesia. So this is a video of a kid who has tardive dyskinesia. I apologize, the video is actually quite uncomfortable to watch. So he's actually trying to sit perfectly still, and all of those motions there are involuntary because of his disease. And so Dan told me about this disease, and he said, you know, there's this test for this disease that involves, your doctor gives you, where you sit still with your hands between your knees, and the doctor subjectively evaluates how much you're moving around, and if that changes rapidly, then that means you possibly have this disease, and maybe your meds need to get changed. But the problem is that 10 minutes of doctor-patient time is really expensive. It can only be done with patients in person. And so I said, you know, that sounds like the perfect thing for the Kinect. The Kinect, if there's anyone who doesn't know, is a peripheral for the Xbox that is a depth camera, and with some middleware lets you get, in real time, the position of a user's joints. So within a day, I'd built a little prototype application that could perform that test itself, track the motion of the person's joints, and evaluate the test. And instead of the kind of approximate subjective view of the doctor, it gave millimeter precision. And so we ended up winning this National Health 2.0 challenge. And then a student at NYU ITP has taken it up as her thesis. And she just published a paper in the American Biomechanical Society about it. And we're looking at, hopefully by the end of the month, having some funding come through for a study at Tufts to actually prove that this technology does the same thing that a doctor would do. It gets the same results, which means that it can then actually go into use with insurance companies and whatnot. So this is for $150 of a Kinect and a bunch of open source software processing and some libraries in that. I, with no medical background, was able to collaborate with a psychiatrist and, you know, make this test that may actually really help people from this degenerative disease, and possibly also start a company with it too. So.
Yeah, great. Hey, Greg, before you do, I mean, disrupting sort of medical technology is I think, one of the potential areas for a lot of the maker technology.
Definitely.
Even we're talking about 3D printed jaws and lots of things. So it's a very rich area, isn't it?
Yeah, definitely. And the Kinect is really powerful for that area because people have great ideas for hardware, and I think there's going to be a lot of open source hardware coming into medical space. But the Kinect is kind of getting there first because just pointing a camera at someone, there's a lot less regulation you need to go through. You're not going to set someone on fire. You're not going to. There's just an IRB approval process rather than a kind of device approval process, right. Which means you can try things out very quickly.
Right. One last thing before you go. You have a project called Make Mathematics, and I'd love you to tell people about it.
Yeah, so I discovered in doing this stuff that mathematics kind of comes up a lot in all of these spaces. You know, we've learned how to teach programming to artists and designers in the last 10 years, but when you're doing 3D fabrication or computer vision or big data analysis, you end up having to actually use some math. So I've discovered, like, I'm having to learn and teach linear algebra and machine learning and principal component analysis. And there aren't as many good tools out there for teaching those things. If you even look at the Wikipedia pages for some of those topics, they're kind of impenetrable. They're written for mathematicians to other mathematicians. So I'm trying to find ways of teaching that material to absolute beginners with really an eye on using it for things. So not as this kind of cold, whole field that you have to learn, but just learn a little bit of linear algebra, and maybe you can detect the taco truck on your corner using a camera, or you can generate some 3D geometry that'll print successfully on a MakerBot. And it's really a generational task we're going to have to do here of the same way we kind of got our arms a little bit around some microcontroller programming and a little bit of OpenCV. There's now more stuff that we've got to learn to let way more people do these applications than can currently do them.
Okay, great. Eric,
thank
you, Greg. You'll be talking tomorrow more about the Kinect platform. Thank you, Greg. Riley, are you in the audience? Riley? Yeah, come on up here. And Vernon, bring Vernon up here. back on the 3D printing thing. Come on up, guys. Our guests here. So these guys are 8th graders, and they're 3D printing enthusiasts. And just tell us what you've been doing.
We actually started out back in 6th grade when we were working on a project for the Tech Challenge, which is part of the Bay Area Tech Museum sort of project setup. What we had to do was kind of rescue abandoned satellite. But the cool thing is we got 3D design software and did a failure analysis on that. And we got introduced to 3D printing through that. One of our parent helpers, Elise Moss, worked up at a place up at Laney College in Oakland, and they had a printer. She printed a part for us, and this sort of piqued our interest. About a year later, 3D Systems contacted us. They're another company who makes 3D printers, everything from the big ZBrush printers down to hobbyist ones like the Ratman. They gave us a Ratman kit, and we built it, and we're now running a class at our school just through stuff we've gotten donated.
That's awesome. And Ray, do you want to talk a little bit about what you've been doing?
Well, we've been just creating a whole bunch of things. Like our teachers, Riley's dad, and another parent at our school have been just giving us challenges to print, there's physical constraints for a 3D printer, how to overcome those, come up with new cool ideas like mechanical objects instead of just standalone, here's a brick, but a brick that moves and stuff like that. So we've just been doing a bunch of those things and teaching the little kids, and it's been actually going pretty well.
Should we have 3D printers in every school?
Definitely.
Okay, good. Thanks, guys. So, I mean, we're talking about innovation here, but the other, I think, leg of the maker movement is education, and being able to get access to these tools and being able to do this stuff in 8th grade. You know, can you imagine where that'll be, in a number of years? Eric, do you want to come down here?
Sure.
So our last sort of just guest is Eric Gradman of Sin Labs, and I think they have a unique business model, which I don't understand, but
You're not the only one.
they get to dress like this and do cool things. So tell us, you have a bunch of things that you're going to demonstrate, but if you don't know Sin Labs, what's one of the signature things that they probably have seen?
Oh gosh, well, people tend to remember Sin Labs because of this giant Rube Goldberg machine that we made for the band OK Go. A 2-story building filled with stuff knocking into other stuff, bumping other stuff over onto the floor, and essentially dancing with the band. And this went on for minutes and minutes and minutes, and was a ton of fun to make.
So basically, yeah, it was awesome. So what I mean by business model, you've kind of got large companies and agencies that are pay you to build really cool things.
Absolutely. Well, I mean, I could go through some of the weird things that we've been enabled to do. Actually, what I want to do first, I want to thank you so much for giving me the opportunity to say thank you to all the people in this audience who've made open source hardware contributions that have enabled me to quit my job and start doing this full time. This is what I do now, is I just make stuff with the raw materials that the open source and open hardware communities are producing every single day, and it's changed my life so much for the better. My background's in robotics, and I found myself at my dream job building robots, but we would get this really expensive hardware in with which I would use to make robots with computer vision and automation technology and stuff like that. And I'm looking at what the open source and open hardware communities were producing and going, oh, I can do this for 1/10 of the cost with the stuff I can buy off their site right now. And so this is what I started doing, and I started buying this stuff and prototyping this stuff at home. When I'd buy one for work, I'd buy one at home. Now, I can't tell anybody what I was working on at this secretive company, and for that reason, I would go home and make my own stuff. And I wound up with mountains of prototypes that sort of exhibited the same advanced behaviors as robots that we were spending hundreds of thousands of dollars building. And And at that time, I met a whole bunch of other people like myself who were in the same position, using open hardware and using open source technologies to make fun things. And we wound up getting together essentially in a bar. We called ourselves a drinking club with an art problem. And we would just sit around and buy this stuff and try and come up with projects to one-up one another. Who can make the flashiest thing? And we were doing this to entertain people at events and concerts and bringing these toys and showing them off. We worked with Kinect, we worked with Arduino, we were 3D printing, we were 3D scanning, we were using open source software, open source hardware, and just making tons of stuff. Just prolific output of this stuff. And that's when we wound up doing this OK Go Rube Goldberg machine. Now that was sort of an aside. There is, as it turns out, no such thing as a Rube Goldberg machine expert. We do have a physicist who understands how fast things fall to the ground, but that's about the best we got. And after we were done with that project, what do we do now? We're a team, and we become a team in this community. And that's when people started finding us to do agency work. And so we started doing a ton of things for advertising and marketing. That's how we found ourselves in the middle of the desert with 24 cars, white cars and black cars. The black cars were stacked up on steel decks, so it looked like a big 24-key piano made of cars. And over the course of a weekend, we're ripping open the hoods and using Arduino-controlled relay boards, a lot of open source software written on the fly in the desert, on my belly, in the dust. We're hooking these cars up to a MIDI keyboard so that when you push a key on the real keyboard, the corresponding car's lights light up and the horn sounds in the right frequency. And we got Gary Newman to come out there, swoop out of the desert and play cars. On the cars. It was so much fun. And it just used all of this stuff that we're talking about. It used the open source software, it used the open source hardware. We found ourselves in New York City recently building an ill-fated window installation for Times Square. And when all our very, very expensive automation failed. Am I allowed to tell this story? It's open source. It's open source. I make a panicked call to Phil, who picked up the phone, thank God, and hooked me up with more Arduinos and boards and breakout boards. And that night, I'm sitting there soldering in the window of the Toys R Us, rebuilding our entire window installation because all of our stuff had completely failed. This SynLabs thing has taken us on an unexpected trajectory. As it turns out, reality television eats people like us alive. So recently, me and two other buddies from SynLabs, we found ourselves on this show, Extreme Makeover Home Edition. Anybody ever seen this? You thought they made houses, right? But now, as it turns out, they brought us in to make high-tech stuff for the houses. And as it turned out, we wound up making stuff to help the people in need. So one of our first projects was making a pitching machine, a baseball pitching machine, for a quadriplegic former minor league baseball player. This guy was in a car accident. He could no longer pitch. He wanted to teach his kids to pitch. And so we bought a pitching machine. We took a bunch of Arduinos, a bunch of servos, a bunch of potentiometers, and we made this thing controllable with his sip and puff machine. So he's controlling the pitch, the speed, and all the settings of this pitching machine with his breath. And when he's ready, he goes, and a ball shoots out the pitching machine as a kid. It was so cool to see this happen. And we did all this with open hardware. We did a PTSD scanner, which basically a wristwatch, which tracked a man with PTSD, his biosigns. And when they got out of whack and he was about to have a PTSD episode, it would notify his wife, you know, maybe it's time to keep an eye on this guy. And finally, after that sort of trajectory of agency work and things like that, I'm finally now back around to working on consumer products and realizing that with this technology, we can really make things to help people, like that pitching machine, stuff like that. I'm making stuff to address my own personal problems first, because I know those best of all. I'm terribly face blind. I meet you the second time, it'll be like I'm meeting you the first time. So I built this device, which you'll see out there on the patio, actually, which is an always-on camera, which is recording all the time. And when I meet somebody, I push the button and it captures the last 30 seconds, uploads it to Mechanical Turk, and anonymous people on the other side of the globe capture the best image of your face, try and figure out your name, transcribe our conversation, and deliver it to my mobile phone. So I have a little bit of like a flashcard. You know, it also correlates it with Facebook. I'm working on my first true consumer, direct-to-consumer product, which is a piece of internet-connected jewelry, which I have outside, and I'm really excited to show people. And all this is made possible because of the output of the open hardware and open source communities. From Kinect hacking to Arduino to Linux to you name it. I have a little bit of maker attention deficit disorder. So if someone has released it for free on the internet, I've built it and made something weird with it, and oftentimes sold it to somebody. So I'm very happy to be a product of this community. Thank you all.
Thank you.